So hello friends and welcome again to the second video of our probability series where our aim is to take you from basics to JEE level. So before we move and attempt JEE level questions, first let's sum up what we have already done. So we have seen what is probability. It is nothing but a measure of the likelihood of any event provided that event is a possible event. So for any possible event, probability always lies between 0 to 1. For example, if we toss a coin, so probability of getting head or probability of getting tail will be 1 by 2. So it can be denoted mathematically as this. Probability will be between 0 to 1. So probability is, as we have already seen, it is a ratio of the favorable outcomes to the total number of possible outcomes. So probability lies between 0 to 1. And if we say that probability of any event and probability of its complement, let's say if we want, if we roll a die and then we want even number, so that is our event. So probability of not getting that even number, that will be our complement of that event. So summation of these two will be always 1. And probability of independent events taken together, so will be the product of individual probabilities. We will be seeing as we move and attempt questions. So automatically these all concepts will be further, will be getting more clarity on these concepts. So already we have covered in our previous video, and the description is already given in the description side. So you can always go and check that video. And so these concepts have already been introduced. So sample space, again quickly summing up. So sample space is the universe of all the possible outcomes of an experiment. So let's say if we toss two coins, so probability, so all the possible outcomes are like we can get two heads if we toss two coins, or we can get one head and one tail. So there will be two cases, one head tail and either tail head, and we can get two tails. So there are total possible four outcomes are possible as we have already shown here. So this is our universe, and therefore this is our sample space. An event is any particular subset of that particular sample space or that universe. So if we want one head and one tail, one head and one tail, so our samples, event will be denoted like head tail or tail head. So impossible events which is not possible, sure event which is 100% going to happen, and simple event in which the sample point is only one, like if we want if we toss two coins and if we want two heads, so there will be only one sample point. And compound event is the one in which we get more than one sample point. So again, if let's say in the tossing of two coins we get one head and one tail, so there will be two cases, head tail head. So this is a compound event. Complementary event we have already seen. The summation of these two events, the event and its complement will be 1. Event A or B, also we said union of events. So it is probability of or the event A or event B or both. So if we draw like this, so this is A, this is B. So what we do event A, event B. But because here some common part is there, so we want subtract also to avoid the double counting. So we will be seeing the as and when we solve these questions. Already we have done in the previous video. So event A and B, that is intersection part. So intersection part is denoted like this. So mutually exclusive events. So then nothing is common between them. So when we have to find the probability, we simply can take them separately as two separate events. So now these are some other concepts which are basically there in class 12th. So we have not done this so far as questions are concerned. So we'll be doing in another video where we'll be focusing on only these concepts. But we have already seen what are these terms as far as definitions are concerned. So random experiment, we know random experiment. When the outcomes are well defined, so that experiment is called a random experiment. And uh, for any when we observe the outcome of that particular experiment, so there are only one possible outcome. So outcomes are solely by chance. So we can take again the example of rolling a dice. So if we want, Possible outcomes are well defined because the outcome can be any number from 1 to 6. So therefore outcomes are well defined. So this meets the first requirement. Then the second requirement, only one possible outcome occurs whenever it is rolled. So it is rolled. So either the outcome will be 1 or 2 or 3 or 4 or 5 or 6. So therefore it meets the second requirement also, and outcomes are solely by chance. So if we want a number, like let's say if we want 2 to come, so it is all the probability of getting 2 is 1 by 6. So it is always by chance. It is not certain that always the when we roll a die, so 2 will definitely come. No, there is only a possibility that it will come, and the possibility is 1 by 6. Then the conditional probability is when, let's say again, two boxes are there, A and B, and there are some balls. So if we want to draw a ball from box B, so already condition is given that the ball selected is B, and now find the probability of getting a particular ball from that box. So it is a conditional probability, and Bayes' theorem is just reverse of that. That we have already given that a particular ball has been drawn, and what was the probability that what is the probability that that ball was drawn from box B. So we need to find the source. It is we will see as we solve the problem. So independent events, multiplication of law, we have already seen. So we will not spend much time on these, and now quickly jump to the questions. So this question has already appeared in JEE Mains 2023. So question says three dice are rolled. If the probability of getting different numbers on the three dice is P by Q, then okay, now let's draw this situation. So let's quickly to understand. We will try to show these three dice as like this. So when these three dice are rolled, so probability we want our what is the favorable outcome, that all the numbers appearing on these three rolls are different. So let's for the first die, when we roll, so any number can appear from 1 to 6. So there are total 6 possible outcomes. So what is the probability of all the 6 outcomes will be 6 by 6. Now when we roll the second die, we don't want any number which has already appeared on the first case. So we are left only with 5 options. So probability of getting all those, any number between from those 5 numbers will be 5 by 6. Similarly, when we roll the third die, so we don't want any number which has already come in the first two rolls. So we are left only with 4 options. So definitely any number getting from those 4 numbers will be 4 by 6. So probability of getting in different numbers will be this. So it can be solved 5 into 4 divided by 6 into 6. So 2 into 2. So this can be simplified. So 5 by 9. And now it says the probability, this probability is P by Q. So this is P by Q, and also P and Q are co-primes. So we can see, sorry. So we can see these numbers are co-primes. So what it says, Q minus P. So Q minus P is equal to 9 minus 4. Sorry, 9 minus 5 is equal to 4. So that's our answer. Now let's move to the next question. This again has appeared in 2023. So a pair of dice is thrown 5 times. Pair of dice. Now you don't have to make these figures or dice and your actual when you're writing the exam, or even when you're practicing at home. This is just to illustrate so that the picture becomes clear. But otherwise, it simply you can visualize in your mind. It is not required to draw all the time. So a pair of dice is thrown 5 times. Fine, it is thrown 5 times. For each throw, a total of 5 is considered success. Okay, if the sum is 5, then it is our success. Otherwise, it is a failure or not a success. So how 5 can appear? 5 can appear in two ways, either 1 4 or 2 3. And 1 4 will have two cases, 1 4 and 4 1. 2 3 will also have two cases, 2 3 or 3 2. So our probability of getting sum is equal to 5 will be sum of these two events. Okay, so probability of getting 1 4 will be 1 by 6 into 1 by 6. Probability of getting 1 is 1 by 6. Probability of getting 4 is 1 by 6. There are two cases, so into 2. Similarly, probability of getting 2 is 1 by 6. Probability of getting 3 is 1 by 6 again, and they are total 2 cases. So we are now 4 divided by 36, which is 4 divided by, 1 divided by 9. Now see the next part. If the probability of at least 4 success is this much, so we will draw a small section here. Probability of getting at least 4 success. So at least 4 success is nothing but probability of getting 4 success and 1 failure, or probability of getting all the 5 successes, because the requirement is that it should be at least 4, so 5 will also suffice. So we will little bit so we will clear some space for us to write. So let's yeah. So probability of getting 4 success and 1 failure will be how much? So probability of getting 4 success, our success probability is 1 by 9. So probability of failure we can write as 8 by 9, that is 1, because it is 1 minus 1 by 9, so it will be 8 by 9. So probability of getting 4 success and 1 failure, so it will be 4 successes means 1 by 9 to the power 4. Why to the power 4? Because we want that it 4 times sum of 5 will come. So 4 times 1, 2, 3, 4, 5. So 4 times here also sum of 9, sum of 5 is coming, here also, here also, here also. So total 1 by 9 into so 4 times. So it can be written like this. And similarly into probability of getting 1 failure. So we have seen it is 8 by 9, 8 by 9. Now this also needs to be arranged, because 4 successes and 1 failure. So total factorial 5 divided by factorial 4 plus all the 5 successes. So 1 by 9 to the power 5. Now this we can solve. So we can again make some space here. Let's remove this part. So yeah. So when we have seen here that this number we can find. So we can take 1 by 9 to the power 5 as common. So what we will be left with? We will left with here 8, and 8 into 5 plus here 1. So and this says this probability is equal to k divided by 3 to the power 11. Okay, so now 1 divided by 3 to the power 2, and this will be 5 into 8 plus 8 into 5 40, and plus 41 is equal to k. So what we can do, that is k is equal to 3 to the power 11 divided by 3 to the power 10 from here into 41. So it will be 3 into 41, 3, so 123. So 123 is here. So with this, now move to the next question. Let's see a bolt factory. Machines in a bolt factory, there are 3 machines A, B, and C, and manufactures respectively 20%, 30%, 50% of the total bolt. Okay, so here is the machine A, here is the B and C. So we will write shortly as manufacturing. So it manufactures 20%, then 30%, then 50%. We can also ignore percentage for time being. And out of their output, 3, 4, and 2% are respectively defective bolts. Okay, so we will again make one column for defective. So 3%. So 3% of 20 will be roughly points. It will be 0.6. So we will consider this as 6 for simplicity, for the sake of, because ultimately its probability is going to be a ratio only, and if all the decimals are ignored and same range, so it will not affect our answer. So Then for second case, the defective person are 4%. So 4% of 30 will be, we can write it 12, and 2% of 50 we can again write it like 10. Now a bolt is drawn at random from the product. Okay, if the bolt drawn is found defective, okay, if it is found defective, then the probability that it is manufactured by machine C. See here, it's in the concept of total probability or base theorem will be applied, because we are already given this that the ball drawn is a defective one. Now find the probability that it has been drawn from, it was manufactured by machine C. Okay, so we need to find the source. So we will see how it is solved. So probability of getting that ball from machine C, given that the bolt drawn was defective. I've written this in just notation form. You understand that what it says, this whole term, that given that already a bolt drawn is a defective bolt. So what is the probability that it was manufactured by machine C? So it can be written like this: probability of of drawing a defective ball from from machine C multiplied by selection of machine C, probability of C, then total probability. Sum of total probability will be, let's say the bolt drawn was from machine A. So what is the probability of getting it? The bolt drawn was defective. Like will be like this. So similarly for B, defective, we will see how this particular thing is derived in next session. This is coming from our conditional and base theorem, conditional probability and base theorem. So when we see the concept part as far as this derivation of these terminologies into this form is concerned, we will be seeing in this part. But intuitively we can understand that why we are writing it like this. So then probability of B, similarly for C, P defective and PC. So probability of getting any machine will be 1 by 3. And let's see, in first case defective from C. So in C we have 6, in 6C we have 10 defective balls. So probability of getting, it will be 10 multiplied by 1 by 3. Similarly for A it will be 6 multiplied by 1 by 3 plus from B it will be 12 multiplied by 1 by 3 plus from C again it will be 10 into 1 by 3. So 10 divided by 6 plus 12 plus 10, which is 10 divided by what we can write. So 10 plus 12 is 22 plus 28. So 5 by 14. So yeah, our answer is here. So now move to the next question. Let n denote the sum of numbers obtained when two dice are rolled. Okay. If the probability that 2n is less than n factorial is m by n, where m and are co-primes, then we need to find this term. So n denote the sum of the numbers obtained when two dice are rolled. So two dice are rolled like this, and their sum, whatever number is coming on those dice, their sum is denoted as n. So if the probability that 2n is less than factorial n, so we will see. So when two dice are rolled, so the sum can take any number from 2 to 12, because the least number on any dice is 1. So minimum sum will be 2, and the maximum number on any dice is 6. So the maximum sum can come as 12. 6 plus 6, 12. So it will be, n will be between 2 to 12. So for each cases we will see that on from which number onwards this requirement gets fulfilled. So when our n is 2, when n is 2, so this will be 2 into 2, 4, and factorial n is 2. So 4 is greater than 2, so this is not our required condition. When n is 3, so here it will be 2 into 3, 6, and factorial of 3 will be 6, so it is equal. So this is also not a required condition. When n is equal to 4, so 4 into 2 is 8, and factorial of 4. Factorial of 4 is how much? 4 into 3 into 2. So that means 24. So yes. So 8 is less than factorial 4. So this is our required conditions. So and when n is 5, so this will be 10, and factorial of 5 will be how much? It will be 120. So yes, so we can see that as we move from 4 onwards, so and the requirement will be met. So that means n is required to be between 4 to 12. Means n can take any value from 4 to 12 to, as per this requirement, to meet this requirement. So now essentially what we are trying to find now, we are trying to find that what is the probability that our n, that is sum of these two dice, when we roll these two dice, so sum of the numbers which is coming on these two dice is between 4 to 12. So 4 to 12, because numbers are more, so what we can do, we can find a reverse, that is complement of that this event. So if we say that probability of getting number which is less than 4, okay, so this will be our getting probability of getting our number between 4 to 12 will be this much. So we are trying to find now this. So 1 minus p, and n can take any value from 2, because some can be on the minimum side, it can be 2. So 2 or 3, it should be less than 4. So only 2 and 3 are left. So we will see each of these cases one by one. So probability of getting number 2. So it will be only in case when I get 1 and 1 on each of these two dice. So getting 1 is, probability of getting 1 is 1 by 6, and again 1 by 6. So it will be 1 by 36. And for 3, so when n is 3, so we can get in two cases, 1, 2 or 2, 1. So 1 by 36 into 2. So we can write it at like this, 1 2 by 36. The summation of these two will be, we will write here 1 minus p. So we will write like this. Yeah, so this we have found, probability of getting 2 is 1 by 36, plus probability of getting 3 is 2 by 36. So it will be 1 minus 3 by 36. So it can be solved. So 1 minus 1 by 12, so which is 11 by 12. So probability of getting any number from sum from 4 to 12 will be 11 by 12. I will try to create some space here. So yeah, let's see. So now it says it is m by n. This probability is m by n, 11 by 12. So, and these two are co-primes. We can see these two are co-primes. So 4m minus 3n, that is 4m is 44 minus 36. So it will be 8. So answer is here. Now let's move to the next question. Again, this question has appeared in JEE 2023. So let a die be rolled n times. Let the probability of getting odd numbers 7 times be equal to the probability of getting odd numbers 9 times. So we know that probability of getting even number is 1 by 2. Why? Because total number of events are how many? So it is they are 2, 4, 6. Total 6 possible outcomes, and total number of outcomes on a dice is 6. So 3 divided by 6 will be 2. Similarly, for odd number, getting any odd number will be, probability will be 1 by 2. So let the probability of getting odd numbers 7 times. Okay, so this die has been rolled n times. So probability of getting odd number, so getting odd number probability will be 1 by 2, and getting it 7 times. So it will be to the power 7, because 7 different number of times we are getting odd numbers multiplied by. Then for left of the options, that is n minus 7, it will be coming even numbers. So for even also it is 1 by 2 probability, and this will be n minus 7, and then we also need to arrange. So factorial n divided by 7 into n minus 7 factorial. So Ashok, why we are doing this? If any of you have any question, confusion or query, आपको नहीं समझ में आ रहा है कि ये चीज़ क्यों किया है हमने, please write to us in a comment because this is very important. Once if we are not knowing that, if we are not very clear that why we do this particular thing, so we need to be very clear fundamentally, otherwise all the questions we will be doing wrong. Though we will be writing these things, but if we don't do this, so it will be fundamentally wrong. So therefore, if any of you don't understand this particular term, so please write to us in a comment box and we'll definitely get back and we'll provide a detailed explanation, or if required, then we will go to fundamental level and we will see taking a simple case, and then we will see why it comes here. So okay, then this is equal to probability of getting odd number 9 times. So again, probability of getting odd number is like this, and this is 9 to the power 9. So probability of getting even number will be n minus 9, and again factorial n divided by 9 factorial divided by n minus 9 factorial. So it can be simplified, so it will be 1 by 2 to the power n because 7 and n minus 7 are there. Then factorial n, this will be kept as it is. Then here again 1 by 2 to the power, here also minus n minus 9 and n 9. So it will be again 9 factorial n divided by 9 factorial and n minus 9 factorial. So we can see that these terms will get cancelled out. So we'll be left with, so n minus n minus 7 factorial divided by n minus 9 factorial is equal to 9 factorial divided by 7 factorial. So then n minus 7, n minus 8, and the other term will be cancelled out with n minus 9 factorial is equal to 9 into 8, and only 7 factorial will be cancelled out. So this can be simplified quadratic equation. So n square minus 8 minus 7, so minus 15n plus 56 minus 9 into 8, 72. So then n square minus 15n, and this will be how much? 12 minus 6 is 6, this will be 16. So this can be solved. So n minus 16 and n plus 1 is equal to 0, that is n is equal to 16 or n is equal to minus 1. So definitely minus number is invalid because here it is can be only an absolute number, positive value. So n is our 16. So we know that this die has been rolled 16 times. Now we will see the other part of the question where it says that if the probability of getting even number twice is this much, then find the value of k. So we will do what? We will remove this part. So how can we then? We again will apply this thing that you know that if the probability of getting even numbers twice, so even numbers, probability of getting even numbers twice, so it will be 2 times multiplied by, then odd numbers will be how many times it has been rolled? 16 times. So 14, probability of getting 40 odd number. Then again factorial 16 divided by factorial 2 into factorial 14 is our k divided by 2 to the power 15. So now what we can do, we can take our 1 to the power 2 to the power 15 as common. So what we will be left with, we will be then having only 1 to the power 1 to the power 2 into only 1. Okay, and then here 16, 15, 14 factorial will get cancelled. Here 2. So again 1 to the power 2 to the power 15 multiplied by 2 into 2, 4 into 4, so it will be 60. So we can see that this will get cancelled. So our k is 60. So k is 60, yeah. So with this, we will move to the next question. Let the probability of getting head for a biased coin is 1 by 4. The coin is biased, so probability of getting head is 1 by 4. So definitely probability of getting a tail will be 3 by 4. If it is tossed repeatedly until a head appears. Okay, so it will be kept on tossing, until the time we get a head. So let n be the number of tosses required. Okay, so total number of times it is tossed is n. If the so this is for what? This is till the time we get a head. If the probability that the equation has no real roots. So we know when the equation will have no real roots when b square is less than 4ac. So in this case, we know that what is our b? B is our 5n. So 25n square is less than 4 times a and c. A is our 64. So 64 and c is our 1. So from this we can find our n. So n square is less than 4 into 64 divided by 25. That is n. We can take the square root on the other side. So it will be 2 into 8 divided by 5. So it will be less than 16 divided by 5. So it will be less than 3.2. So that means because n is our number of tosses, so it is only an integer number. So n can have any value from 1 to 3. It has to be less than 3.2. So 1 to 3. So now we have seen, so we will remember that n is our any number from 1 to 3. We will remove the other part to create space for us to solve the next part. So now let's see. Yeah. So the question says, the next part, that if the probability that the equation has no real roots is p by q, where q and p are common, then q minus p is equal to, okay, so probability of, so this is the probability of getting n is q by p, sorry, p by q. So our n is 1, 2, 3. So let's say take each of the cases one by one. So when our n is 1, so the n is 1 means what? When our n is 1, it means a head has appeared on the first choice itself. When we toss the coin first time, the head has appeared. So probability of getting head will be it will be 1 by 4. Or when n is equal to 2. So when we toss the coin first time, we are not getting head. So the probability of getting tail will be 3 by 4 multiplied by, now the second time when we toss the coins, we are getting head. So it will be 1 by 4. Now, then when when we toss the coin third time, n is equal to 3. So first time we are not getting head, so it will be 3 by 4. Second time also we are not getting head, 3 by 4. And third time we are getting a head, so 1 by 4. 1 by 4 can be taken out common, so it will be 1 plus 3 by 16 plus it will be 9 by 16. It can be solved. 1 by 4 multiplied by LCM will be 16. Here it will be 16. Here it will be here it is, sorry, it is here 4. So 12, and here it is 9. So 1 by 4 into 37 by 16. So 37 divided by 64. So these two are co-primes also, we can see from basis p by q, and p by q are co-primes. So q minus p is equal to 64 minus 37. So it will be 27. So answer will be 27. Now let's move to the next question. A biased coin. okay, is tossed repeatedly and independently until the first head is observed. Okay, so it is tossed, n number of times till the time we get a head, and the probability of getting head is q, where q is more than 0. Definitely, it has to be. So, compute the probability that the first head appears at an even numbered toss. At an even numbered toss. So, let's simply draw some cases. So, first toss, then the second toss, then the third toss, then the fourth toss. So, probability of getting a head at an even numbered toss. So, we get head at either second position or we get head at the fourth toss, or similarly until the time we get head. So, probability of getting head on the second toss. So, when that means we are not getting head on the first toss. So, probability of head is p. So, probability of tail will be 1 minus p. So, it is 1 minus p multiplied by p, plus we are not getting head in or if we don't get head on the second time, so we want our head to come on the fourth time. So, that means 3 times we are not getting head. So, 1 minus p to the power 3 multiplied by again p. Fourth time we have got the head. Similarly, if it's on sixth time also if we are getting head, so that means 5 times we are not getting head, and then sixth time, and similarly it will go on. So what we can do, we can take out 1 minus p multiplied by p as common. So here will be left with only 1. So here 1 minus p whole square, 1 minus p whole to the power 4, and likewise. So we can see this is a geometric progression where the the terms are going to infinite number of times. So sum will be here, this sum will be a divided by 1 minus r, and our a is 1. So 1, and our r is 1 minus p whole square, 1 minus p whole square. So it can be solved, 1 minus 1 minus p square plus 2p. So it will be like 1 divided by p minus 2. So this sum is like this. So we can then put these figures multiplied by 1 p minus, here it is 2p. So 2p. So our 1 minus p divided by p minus 2p. So C is our answer. Now let's now see the next question. This has come in mains, JEE Mains 2020. So probability of a man hitting a target is 1 by 10. Okay. The least number of shots required so that the probability of his hitting the target at least once is greater than 1 by 4. So, probability of a man hitting a target. So, let's denote it like this. Hitting the target is 1 by 10. So, not hitting the target will be 9 by 10. Now, at least number of the least number of shots required so that probability of his hitting the target at least once is greater than 1 by 4. So, now we need to find that probability. So, then at least one shot, uh, you know getting a hit at least once. We will write like this. Probability of getting at least one hit will be 1 minus probability of getting no hit, that is 1 minus p to the power ph bar, or complement of h. So, and number of times, let's say that this number of shots are n. So, it will be like this, 1 minus 9 by 10 to the power n, and this is greater than 1 by 4. So, this is greater than 1 by 4. So, we need to solve this particular term and we will get our answer. So, 1 minus 9 to the power is this much, this 1 by 4. So, 9 to the power 10, so it will go the other side, so it will be like this, 3 by 4. Now, we can see this term 9 by 10 is 0.1 and this is 0.75, so on a number line 0 and 1. So 0.75, let's say somewhere here, and point 0.9 point, this is 0.9. So this is 0.9 is here. So we want the number n where 9 by 10 to the power n takes the value less than 3 by 4. So we want this particular thing to come to fall anywhere from here to here. So when we take the numbers, like if we do square, so it will be 0.81. So again it is more than 0.75. When we do the cube of 0.9, so it will be uh, so it will be like 9. So it will be less than 0.75. So for any number which are more than 3, so it will 9 by 10 to the power n will fall here, which is our required position. So n will be, that means more than, greater than or equal to 3. So least value of n will be 3. Therefore our answer is 3. An ordinary dice is rolled for a certain number of times. If the probability of getting an odd number is 2 times is equal to the probability of getting an even number 3 times, then the probability of getting an odd number, we have already seen this type of question earlier, so I will request you all to please try and solve, and if you find any problem, so definitely we'll come back to you, provided you request to us or maybe write in a comment box. So we will encourage you to please solve this question. And again, see this question which has come in JEE Main 2018. So bag contains 4 red and 6 black balls. So 4 red and 6 black balls. This is the bag. A ball is drawn at random from the bag. Its color is observed, and then this ball again with 2 additional balls of the same color are returned to the bag. So if now a ball is drawn, then from the bag, then the probability that this ball drawn is red. Okay. So it says when we draw a ball, so there can be either red ball drawn or can be a black ball drawn. There are 2 cases. Let's say when the ball is drawn, it is a red ball. So then 2 more this ball and plus 2 more red balls, 2 additional balls. 2 more red balls will be sent back to the box. So the total number of red balls will be now 6 red balls and 6 black balls. And in the second case, if the ball drawn is a black ball, so the total number of balls in the bag will be 4 red and 8 black, because 2 more black balls will be returned back in addition to the original ball drawn. So it will be like this. So these 2 probabilities only we need to find. So let's say first case, so it is drawing a red ball. Drawing a red ball will be, probability will be 4 divided by 10, 4 divided by 10. Then drawing a, so we are trying to find the probability of ultimately drawing a red ball. So then once we have already drawn the red ball, so now again drawing a red ball, so this number of balls will be like this. So 6 divided by 12. Or if in the first case, if we have drawn a black ball, so drawing a black ball, its probability will be how much? So it will be 6 by 10, 6 divided by total 6 plus 4, 10, multiplied by, now we want to draw a red ball, so it will be 4 divided by 12. Okay, so this is nothing but same term. So 4 divided by 10 into 6 divided by 12 into 2. So 6 into 2, 12, so it will be cancelled, 2 into 2, and so this is 2 by 5. So with this, we are ending this today's session, and we will request you all to please try and solve all these questions once again. Please take a screenshot. And one question which we have not done, because already similar question we did in a few questions back. So we'll request you all to please solve, and if any problem, so please write to us, and also please don't forget to like, comment, share and subscribe this channel. So thank you, and we'll be meeting again in next video with the topic covered in that video will be on conditional probability and the similar topics associated. Thank you.